Dear students, I start with lecture 7 of Mat 201. In the previous lectures, we have learned that the first definition of directional derivative. In this definition, the definition is like this: d of fx bar along u bar is equal to limit h tends to 0 f of x bar plus hu bar minus fx bar upon h. This is definition of directional derivative, and u is unit vector. And then I explain you that, then I say to you that this definition is very much similar to the partial derivation. All this definition we have discussed in the previous lecture. So just see that this one and the definition of partial derivation, what you understand, then I will give the brief detailed introduction of the partial derivation. Again, I have once you explained all about all these things, but in this lecture I want to much clarify the same concept, because it is with you up to where you learn mathematics. How much you will learn mathematics, this concept is required in a thorough throughout, and it must be crystal clear to you. Instead of that, this is the definition. Now what I suggest, say x bar is a point AB, and for u bar I say it is E1, say 1, 3. Now what is derivation as per this definition? Means it is d. Obviously, norm of u bar is norm of u1, square root of 1 square, 0 square, and obviously it is 1. After some time, if we take u equal to e2 is equal to 0, 1, and what is the norm of u2? Again, to understand, it is 1. Square root of 0 square plus 1 square, square root of 1, and so it is 1. I think it is understandable. Now d of f of x bar means f at point AB along E1. As this is E1, I used to say this is f of x at point AB. Now see the beauty of this definition. Now this is equal to limit h tends to 0 f of x bar plus he1 means f of x bar means it is AB plus h into 1, 0 minus f at point AB upon h. Now this is equal to limit x tends to 0 f of a plus h b minus f of AB upon h, and this is known as partial derivation with respect to x. Here you can see that there is a difference in x coordinate and y coordinate remains constant. Now if we apply the same definition, if we take u equal to e2, then what will happen? Therefore d of e2 f of AB is limit. I change the h to k. There is nothing special about it. Okay, it's just a number which is tends to 0. F of AB plus ke2, ke2 that is 0, minus f of AB upon k, and this is equal to limit k tends to 0, f of a b plus k minus f of ab upon k. And you see that there is a difference in the y coordinate and x coordinate remain constant, and this is partial derivation of f with respect to y at point A. So these are the definitions, are a sub-definition of directional derivation. Means this is in the differentiation in the direction of x, and this is differentiation in the direction of y. Try to get this idea. Next, I define total differentiation. Now the definition of total differentiation f of definition of differentiation. Do you remember definition of differentiation? That is dy by dx. But that definition, that is a symbol. But the definition is difference of y coordinate dy by dx, but the definition is different. Definition of differentiation is what? F dash x is limit h tends to 0. Just recall, I give you hint. Recall f of x plus h minus fx upon h. This is definition of differentiation of function f at point x. Okay, you should remember this. But this definition is in one dimension. Now whatever I say, this is in two dimension. F of x plus h y plus k is equal to f of xy plus kh Vk epsilon rho, where value of rho is square root of h square plus t square. A and B are constant. They are constants and they are not dependent on h and k. And this tends to 0 implies epsilon tends to 0. Then we say that this function is differentiable at point x1. Just see that. Or one way you can write limit rho tends to 0, x plus h, y plus k, minus f of xy, minus ah, minus bk upon rho, and this is value of epsilon, and therefore this is equal to 0. Either way you can say that if epsilon tends rho tends to 0 implies epsilon tends to 0. This is a definition of differentiation and it is totally different and as we understand in the one dimension. Now if we change the side of this and that side, it is minus f of xy minus ah minus bk upon epsilon. And here value of rho is square root of h square plus k square and that tends to 0. So if you think this in two dimension, suppose I say this point say xy. That means that if we draw the figure perpendicular on x and y axis, then this will be x and this will be y. And this point say x plus h, y plus t. Just think that. And again if we draw the figure perpendicular from that, then it is perpendicular to the relative axis. Then this distance is x plus h and this distance is y plus k. Means this distance is k and this distance is h. Now if we this is k means this is k and this is h and this is 12 of h square plus k square and we call it rho. This is tends to 0. Then this is tends to 0. Keep this picture clear in your mind. So this is tends to 0 means this distance is very negligible and this limit is equal to 0. Means h and k tends to 0 obviously because rho is square root of h square plus k square. If that tends to 0 obviously h and k tends to 0. But this tends to 0 implies epsilon tends to 0. This means that this limit is equal to 0 and at that time we say that this function f is differentiable at point x y. But there are so many different hidden facts are there in this definition. Just I explain you how it is. You should keep this definition. You should keep this definition for your reference. I say that you keep this in your mind. It is on the board, but you should keep this in your mind. See here, if it happens, say k equal to 0, if k equal to 0, it implies rho equal to square root of x square plus 0 square. Can I say that is h? Yes, it is. And more clearly, it should be mod h. Or think that it is positive, whatever. Now, this is tends to 0. Implies h tends to 0. Obviously. So this definition becomes what? Limit h tends to 0. F of x plus h y, because a is 0 is equal to f x y plus a h plus b 0 epsilon into mod h or x. Rho is h or mod h minus h or plus h. Simplify this. This implies a equal to, this is tends to 0. We can say h in common means a plus epsilon upon h. Now if I take limit h tends to 0, then this epsilon is 0. And if I take limit h tends to 0, then this is f of x. This is partial derivation of function f at point xy. And that is value of a. This is beauty of that. Further in the same context, if I say h0 means this is k square, this is 0, means this is mod k, means k tends to 0. What this equation becomes? This equation becomes now here x0 means it is f of x, y plus k is f of x y. This is not there, means f into 0 plus bk epsilon rho is k. You can write k or mod k, I have no problem. Actually, we have no problem. And these things gives us, if we change the side of this one on that side, means it is x, y plus k minus f of xy is equal to b plus epsilon into k. But we put this k on that side. We put this k on that side. We are taking k in common. This is 0, means it is not in the calculation. Clear? Now take the limit. K tends to 0. This epsilon is 0. On this side, what is value of b? That is f of y point xy. And though in the definition I said that a and b are independent of x and k, recall that. Now, this definition is modified. Means f of x at point xy into h, f of y xy into k. Now Now this is definition of differentiation. Here there is so many things, but I will explain you as we are going further in the syllabus. I stop here for this lecture. Thank you very much.